there's this next problem, which is a different kind of a problem. We're given two triangles, and we're given some of the angles. We're asked to list the sides in order from shortest to longest. Okay, so this takes a little bit of thought. Again, it's not at first a very easy problem, but we can use some of the properties that we know that relate the size of angles to the size of triangles to figure out how to rank these sides from shortest to longest. The first thing we're going to need to do, and let's start with problem 14, is to fill in wherever we do not have angles. So we've got to fill in the missing angles, and I'm going to go ahead and take my calculator out here. You don't see it, but this is going to help me out. So this first triangle on the top, ABD, I've got a 15 degrees and a 42 degrees, but I do not know this third triangle. I know these three have to add up to 180, so 15 plus 42 is equal to 57, and that makes this remaining angle 123. Okay, so, whoa, you're going to say, this angle doesn't look like 123. This is an acute angle, right? 123 is an obtuse angle. Well, look what they said. At the end, triangles are not drawn to scale. Okay, so you need to use what you know from the triangle sum theorem and from the properties of angles and sides, and not expect that these are drawn to scale. Okay, so this one is 123 degrees regardless of the fact it doesn't look like it. Let's now figure out what angle C is. Okay, I've got to add 48 plus 22, which gives me 70, and that makes C 110. Okay, so the first thing I do is I use the triangle sum theorem to ensure that my angles add up to 180 degrees. Now comes the hard part. Okay, I've got to figure out what are the sides from shortest to longest. Well, I know how to do this in individual triangles. So for the moment, let me cover up one of the triangles and just look at the remaining triangle. So in triangle CBD, I can rank these sides from shortest to longest because I know the shortest side is opposite the smallest angle. So I've got DC is less, in terms of its measure, than BC, which has got to be less than BD, because BD is opposite the largest angle, right? Okay, good. So I can do it in that triangle. Now let me try and cover up the triangle I just did, and let me try to come up with inequalities for the remaining triangle. Well, in this triangle, I've got the smallest angle is 15. Again, it doesn't look like it is, but we just have to go by the numbers. 15 is the smallest, so that side BD is got to be smaller than, this is the middle angle, than side AD, which has got to be smaller than the largest side in this triangle, which is AB, because it's opposite the largest angle, AB. Okay, well, I've got two sets of inequalities that have resulted. I've got to somehow combine these two. Is there a way that I can? Take a look at these and tell me what you think. Well, at least to yourself, think about what you can do. Okay, I think you'll notice that both inequalities have BD in common, right? They both have BD in common, so that BD is greater than BC and greater than DC, but BD is also less than AD and less than AB. So we could just combine these two inequalities, move this one up over here, and therefore we have BD is less than AD is less than AB. Okay, I've simply just taken this little string of inequalities and put them up over here because we know them to be true. Now we have one large group of inequalities which contains all the sides, right? We've got 1, 2, 3, 4, 5 sides. And that's the 1, 2, 3, 4, 5 sides in this illustration. And we have listed them, well, we've given them an inequality from shortest to longest. So if we had to list them from shortest to longest, we would simply just list them out. DC, BC, in this case, I'm now listing them as sides, so I'll put a a line above them. And now I have listed the sides from shortest to longest. Okay. That strategy will work for all of these problems. So let's go ahead and do number 15. Remember, our first step always is to find the missing angles. So that's the first thing we want to do, is find the missing angles. So go ahead, use the triangle sum theorem. 65 plus 25 is 90 degrees, right? And that means that this remaining angle has to be 90 degrees. Now, I know that doesn't look like a 90-degree angle, okay? But again, in these problems, you do not use your protractor. They are not drawn to scale. You're not to worry about what they look like. The purpose is to find the number and then to use the numbers. Here we've got 89, 63, and the remaining angle would be, well, this one I might write out a little bit over here. So just remember, we have x plus 63 plus 89 equals 180, and we have to solve for x. So I'm going to do that on my calculator here. I hope you do it on yours. And when I add up 63 plus 89, I get 152. And I subtract that from 180, I get 28. So 28 degrees is going to be my angle there. And if I check by adding it together, 28 plus 63 gives me 91, plus 89 is 180. Okay, so I found the missing angles. I did number 1. 2 is now examine each triangle separately. Examine each triangle separately so that we can come up with individual sets of inequalities. So let's take a look at, and it doesn't really matter which triangle I do first, but let me go ahead, and it's a little bit easier to do the right triangle first. So I've got triangle DBC, and I'm going to go from lowest to highest, from shortest to longest, and the shortest side has got to be opposite the smallest angle, which is 28. So DC has got to be less than the middle angle, which is 63, which is opposite side BC, which is going to be less than BD, which is opposite the largest angle. Okay, now let me go ahead and cover up this triangle and come up with a series of inequalities for the first triangle. On the first triangle, the shortest side is going to be BD. So it's opposite the smallest angle, 25 degrees. So BD is going to be less than, and the middle angle is 65, which is opposite AD, which is less than the largest angle, which is opposite AB. So let's see what that gave us. So again, when we examine each triangle separately, we got this first set of inequalities. Oops, I left out the less than sign there. And this set of inequalities. And can we combine them again? Yep, because we have BD here. We have BD over here. We can put the AD greater than BD over here, and the AB greater than AD over there. So now we have one long chain of inequalities, sort of a mega compound inequality that has all 5 sides. And now we can list the sides from smallest, which is going to be DC, all the way to largest, which is going to be AB. So let's go ahead. That would be DC, comma BC, BD, ED, and AB. That would be the list from shortest to longest.